Hello everyone. Today in this lecture we will discuss about thermodynamics. Thermodynamics basically will discuss a small part of types of processes, types of thermodynamical processes which are there. Number one process is here, if we will see, is isothermal process. See, isothermal means if you break up a word, if you break up this word, iso means same, thermal means temperature. Clear? So isothermal process, what happens up where the temperature remains constant. Now example of this is melting of any substance, boiling of a substance or boiling point or something. For example, you take water is being boiled up. Water which is in a liquid phase will have a equilibrium where water which is in a gaseous phase. Okay, water in a liquid phase, water in a gaseous phase. Now what happens up here? See, here it will be a, means this is reversible reaction, and this reversible reaction happens at a exact temperature of 100 degree Celsius. Means if we are talking of a equilibrium between a liquid and a gas, if we are talking of a equilibrium between a liquid and a gas, then the temperature will be exactly equals to 100 degree, and this temperature, till the time this temperature will remain constant, this equilibrium will be settled. So what do we call this process? This process here will be isothermal. Same, it will go for the freezing of water. Freezing of water, what will happen up here? We are having up a water which is in a liquid form. Now this will freeze. This will freeze water which is in a solid form. Now this freezing of water, the equilibrium between a liquid or a water in a liquid phase and a ice will happens only and only at a temperature at a 0 degree Celsius. So this process is also called as isothermal. Is this clear? Now what happens up next type of processes? Next is adiabatic process. Okay, adiabatic process is very good process. Okay, any process from which there is no passing of heat, means for example heat is neither been gained into that system, heat is neither been released out of that system. So what happens up here in this case? See, for example, you take one thermos flask or hot box where we put our food. Okay, now this thermos flask will be having up a insulated material on the outer side, and inside it will be having up a certain food. Now what happens up here? Because it is a thermal material, it's a thermos flask or it's a hot box, here the heat will neither the heat will enter to the system, nor the heat will move out of the system. Okay, so this system here will be exactly adiabatic. Okay, in reactions or in numericals we write here Q is equals to 0. Q equals to 0. Now we will see one case of adiabatic process. Now adiabatic expansion occurs. Now according to first law of thermodynamics, we know delta U is equals to Q plus of a W. Delta U is equals to Q plus of a W. Now what happens up here? Delta U Q plus of a W, we are having up a adiabatic expansion. So adiabatic Q will be equals to 0. So I will take this thing equals to 0. So my delta U here, my delta U in this case will be equals to work done. Now we write the formula. Delta U is always equals to, for ideal gas, N CV delta T, which is equals to minus of a P external into dV. dV is V final minus of a V initial. What is delta T? It is also T final of minus T initial. So NCV T final minus of a T initial. So minus P external V final minus V initial. Now they are talking of a expansion. They are talking of expansion. Expansion means your V final will be greater than the V initial. Expansion means the process here volume is increasing. So the final volume will be greater than the initial volume. So V final minus V initial, this thing will become over here positive. Now already there is a negative sign, pressure will be positive. So this overall thing will become negative. Here N is positive, CV is positive. Okay, it means T final minus T initial will be negative. It means your T final will be greater than here T final will be less than T initial. Here T final will be less than T initial. It means T final will be less than T initial. It means here my system has been cooled down. That is what they have told over here, cooling. That is what they have told here. So whenever adiabatic expansion occurs, okay, cooling of a system will happen. The same thing, opposite thing will happen, adiabatic compression. Compression means my bigger volume will become up a lower volume. Okay, so what will happen? V final will be less than V initial. Okay, V final will be less than V initial. So it is delta U is equals to Q plus of a W. Delta U equals to U N CV delta T. Q is 0. Work done is minus P external V final minus of a V initial. This time V initial is greater. So this overall value will be negative. This will be positive. So NCV T final minus of a T initial. T final minus T initial. This is positive. It means your T final is greater than T initial. When T final will be greater than T initial? When it will be heated up. So that's why the system is being heated up. So system is heated up. So the system is heated up. Now what happens up in next case here? Isobaric system. Isobaric, same. If you will break up this word, isobaric, same, means here it will be same pressure. It will be having up a same pressure. So for example, boiling of water. See what happens up when we do boiling. Whenever you boil up a water in an open vessel, here you are having up a fire. You are firing it. Okay. Now vapors will go upside. Because the system is open, there will be one pressure which will be acting on it. That is only one pressure, that is P, atmospheric pressure. So you boil up water, you don't boil up water, the pressure will remain always same, that is atmospheric pressure, 1 atmosphere. So this is a isobaric. Okay. So wherever same pressure, it will be isobaric. Same freezing of water, you are freezing up water in a refrigerator. Okay. Pressure will always remain constant. Here you are having up a water, this water will become up a ice. This will become ice. But pressure will always be same. Pressure will be same. Pressure will be same over here. Now what happens up here in this case? Next thing is isochoric. Isochoric means same volume. Volume equals to same or constant. Okay. Now the best example is pressure cooker. We cook food in pressure cooker. What happens in pressure cooker? See, pressure cooker size will always be same. This volume will always remain constant. No matter the inside food, earlier it was less in quantity. If you put up rice, uncooked rice, it will be less in quantity. After cooking up, the rice quantity will increase, but the volume will always be constant. So pressure cooker is the best example. Everything, temperature increase will happen. Okay, everything will happen, work will be done on the system, but total thing, the volume will always remain constant over here. Now the next process is Now, cyclic process. See, cyclic process is any process now where the initial and the final point is same. For example, my process starts from here, A. It goes to B. It goes to B. Then again it starts from B. It comes to A. A process where the initial and the final point, initial point is A and the final point is also A. A process in which initial and the final point is same is called as a cyclic process. Okay, the best example is Carnot cycle. Carnot cycle, it forms something like this over here. This is pressure, this is volume, this will be something like this. Here the initial, it will go, this is the initial point, this is the initial and final point over here. Clear? So this is cyclic process. Now what happens in next process? Irreversible process. Okay, the process which takes place extremely fast. Irreversible means once that process is done, it cannot be reversed. For example, you take one paper, we will take one paper, okay, and we'll start burning it, okay. After 1 minute, what will happen? It will form out ashes over here. Here, ash will be formed out. Now, this process has been done. The ash can never be reversed back to paper. Ash can never be reversed back to paper. This type of process is called as a irreversible process. This type of process is called as irreversible process, means which cannot be reversed back. For example, simple, you take up a dry cell. You take up a simple dry cell. A dry cell, once it is used in a watch, it is being discharged, it cannot be recharged back until unless it is a special rechargeable cell. Okay, a simple dry cell, laboratory cell, or any simple cell will never be recharged back. Once it is discharged, it is a irreversible process. This is a cell. Here it is being discharged. It cannot be here. This backside is not possible. Backside will not be possible in this case. Okay, backside will not be possible. Now see, next is reversible process. Now reversible process, what happens in a reversible process? A process which takes place very, very slowly. Okay, now 1 second. Now the process which takes place very, very slowly, for example, extension of a spring. For example, we are having up a spring. Okay, we are having up a spring over here. Now you start pulling up this spring with certain force. You start pulling it with a certain force. What will happen in next step? Okay, here, next step, the size of the spring will increase. Next step, again the size of the spring will further increase. This type of process which happens up very, very slowly is called as reversible process. Why? Because once you leave this spring, once you take out this force, okay, what will happen up? What will happen up here in this case? This will again become up a same spring. So once you take out a spring, okay, slowly, its length will increase. Once you leave, suddenly it will come back. So this is a reversible process. The process, it has started, it can go in this direction also, it can come back in opposite direction also. So this is about this reversible process. I think these all are the types of process which happens in thermodynamics. Okay, so with this, in this lecture, we'll end up over here. That's all for the day. Thank you.